is talking about the grip rule. You can see the hand here. Do you remember that? Do you remember that sometimes you can use the thumb as the B field as well? It's not always having the thumb to be current. It could be opposite. Yesterday we tried as well. But anyway, number one says, what should happen to your current if you increase the B field? If you want stronger B field, you have, of course, you have stronger current as well, greater or higher current. Just like if you think about the day you build the electromagnet. I saw some of you try to use 2 batteries, and that was quite smart actually. Because if you have 2 batteries, what will increase? The voltage firstly will increase, and then the current will also increase. Because one equation, V equals IR, and R is the same because it's the same wire. I suppose you didn't take more wire, you should same wire, and you just add on battery. That should already increase the strength of the electromagnet, and I mean the B field. Number 2, how can you increase the B field by changing the numbers of turns? You want to have more or less? Common sense, of course, you want to have more. Yeah. Number 3, if you change the direction of current, what will happen to B field? It will reverse. Very easy. Reverse. Yeah, the direction of B field. Just like yesterday, we tried to reverse the direction of currents. You can see the compass go the other way around. And also in the wire, if you remember straight wire, and if you reverse one of them, then it will go the opposite side. Inward to outward or outward to inward. Are you okay with this? Very simple. Let's go to the next page. Okay, now this is a part where you can know a little bit, not entirely, but know a little bit of how come there will be a force, right? Because yesterday what I told you is I just told you, hey, you trust me first, that by using this hand rule, you can find out the force. At least you see the evidence that there is really a force, right? But here is an explanation. Think about this. If you got this magnet, this is a very important diagram. Originally, maybe I can draw somewhere here. You can also draw it as well if you like. Let's say this is the magnet we had yesterday. And how is the B field look like? North to south, so to this side. And what kind of features do you see when I draw it? They are parallel, right? They are straight and parallel like that. Just imagine, these are like nets, some string that connected from this to this. All right, you try to pull it. All right, these are the string, give you some tension. Now think about separately. There is a wire. There is a wire where you want to have some current through it. So for example, like this picture, if I have this as the current, I, how should we draw the B field? If the wire is going in, like this, which hand should you use?
No, right.
Right hand to find out the B field, right? How do we do? How do you do? Yeah, the current going in, and then when you try to grip it, what does that mean? Yeah, the B field should be like circular, and the closest, the more dense, right? The further apart, less dense, so maybe like this. If I draw 3 circles, this at least 3 circles show density, I guess. And you can figure out the direction as well. Clockwise or counterclockwise? Yeah, clockwise. Right? Are you okay with this so far? These two. Yeah? If you add these two simple stuff, this one is simple, this one is also quite simple, if you learned yesterday, together, if you put them together. What I mean is put this wire into this. So this is the green lines here are magnetic field. These are also magnetic field. And they cannot overlap each other, right? That's what we learned previously. They cannot overlap each other. They have to somehow compensate and find out the net field line. And at the end, it will be a bit like this one. And the imagination you can think about is, this is a little bit like the catapult. Or you may think about, these are like, originally these are the nets. And what you want to do is, you put the wire on it, and this wire will have a force that go like clockwise, and it will make the force, it will create the force when these two B field interact with each other. You need some imagination for that. So for this space, you may not know how to fill in. What did you fill in for this blank? Sorry? You don't know?
Chelsea
Okay.
said catapult.
Yeah, so catapult. How do you spell catapult? C A what? T A P U L T, right? Catapult. You know catapult, do you? Like machine that you, let's say rubber band, you pull it and then release, and then it will like get float. A bit like this. Yesterday we tried as well. If we only reverse the direction of current, what will happen to the force? It will reverse the direction of force.
Why?
Simply like, think about your fingers. Let's say this is FBI right now. F is going up. B is like this. I is like that. Now, if you change the current, FBI, change the current. You can just do it with your hand as well. Can you do it with me? FBI. Now you want to change the current. Opposite. Reverse means opposite. So force is downward.
Like this is the.
Oh, because the B field have to be the same.
Yeah, B field has to be the same. So here it's saying you only change current. You only change current. So B field, I can only do rotation. I cannot do change. You can't change it. You can't change B field. At the same time, if I consider these two separately, A or B, different cases separately, again, let's say this is original one. If I change a B field, if I reverse a B field, how should I move? Can you show me with your hand? How should you?
Without changing
the current.
Like this. Flip.
Then it has to be like this.
Without changing current.
Oh, sorry, without changing current. So
Flip.
yeah, it should be like this. So the force will be opposite as well. Yeah, make sure you can try it. Yeah, change B field only, second finger only, and I has to be the same. So you may want to hold this finger and then you will see the force will be opposite, and that's what we see yesterday as well. So this is also reversed. If we do A and B together, you may want to add that A and B together. What will happen to the force?
No change.
No change. Very good. Like what we did yesterday. Can you put that down? Can you guys put it down? If you do these two together, A and B together, then no change to the force. Because you reverse and reverse again, that means nothing. Have you heard of some people always said you turn for 360 degrees?
Yes.
That means you didn't turn. Like the correct explanation is saying, oh, your attitude changed 180 degrees, right? That's the correct way of saying. But someone say, oh, your attitude changed 360 degrees. That means you didn't change. Right? It's the same thing. That's Stupid
Take
problem.
360 degrees. But we change negative velocity.
Okay, last part. I think this is quite obvious. If you understand what we have been doing so far, you should be okay. As long as you understand one thing, what should you pay attention to this? Tell me, what should you pay attention to this? When you have case like proton and electron.
Conventional current.
Very good. You need to figure out the direction of currents. So if you have a beam of electron, then it will be what? The opposite. Very good. Of the direct conventional current direction. So like this one, can you help me to check if this diagram is correct or not? I just Google it. Maybe it's wrong. Who knows? Can you help me to check? Is it correct using your hand rule? What should I do? F I don't know. B is what?
Going in.
In. And I is, for this electron is left or right? Left. Right? So that's why the force is downward. That's why it go downward. Right? And same for positive, because now current is really going to the right. B is in, I is to the right, so F is up. So that's why it turned out.
Proton is right.
Proton. Yeah.
Electron is left.
Yeah.
proton 係你就
Yeah. So you may want to put down, if you think about proton, you guys can write down as well. Proton direction or movement direction more precisely will be the same as conventional current. Because proton is positive. And that's what we thought, I mean, people in the past thought. The positive are moving. So if you look at proton, then you should feel happy. You don't need to do anything. If you see negative, then make sure you opposite the current. Are you okay with this?
Yes.
Yeah? Keep having to cut this.